This is a lesson on resistance in a circuit. We're going to be exploring today how resistance is calculated for different types of circuits. In particular, we're going to explore these formulae. As per the syllabus. So we're going to see how these things work. I'm going to start off with series and parallel circuits. This is also assumed knowledge from junior science, from year 9 science. But we'll do a recap here as well. We'll start off with series. Quite simply, it's a circuit where the components are arranged one after the other, forming one big loop. Think of a TV series. You've got seasons, they come one after the other, right? They come in series consecutively. Same thing with components in a series circuit. We'll draw a quick sketch here. Let's say I've got a battery. And I'll draw 3 light bulbs in series. Okay, and you've got one big loop here. And if you recall, conventional current is defined as the flow of positive charge. Current flowing from the positive terminal of the battery to the negative terminal of the battery. Okay, we typically denote conventional current with capital I. That's a series circuit. Let's look at a parallel circuit. Parallel circuit, as the name suggests, is where you've got components connected in parallel on different branches. Okay, you've got branches in a parallel circuit. Let's draw a parallel circuit. Let's draw a battery. And the 3 light globes we had in the series circuit, let's put those in parallel. Now, I'm not using a ruler here or pencil. I'm hoping that you're using a pencil and ruler. It's common practice to use a pencil and ruler, not only in high school, also after school, by engineers and scientists, physicists. So please make sure you use a ruler. Okay, so we've got branches here. We've got several branches. This is the first branch here, second branch here, and the third branch. And so that's series and that's parallel. Let's look at some pros and cons. With a series circuit, a pro is it's easy to connect. You can make a series circuit simply using a light bulb, light globe, wire, and a battery. That's it. Just 3 components. It'll take you a few seconds if you have the right materials. Another pro is that current is the same throughout the whole circuit. Okay, in other words, there's energy there's electricity is flowing equally across the whole loop in the circuit. So they're the pros. Just like everything in life, there's always going to be cons, right? Cons of a series circuit. One bulb fails, for example, rest fail. Think of your fairy lights, okay, your decorative lights. If one of those fails, the rest fail because there's only one loop. Okay, think of an analogy. Suppose you're running on a road. There's this one road you're running on, and you come across an obstruction in the road, what happens? You can't go anywhere, right? Same thing with current. If there's an obstruction in the circuit, if a globe's gone out, if it's popped, if it's burnt, then the rest fail because there's no current reaching the rest of the globes. Also, adding more bulbs results in dimmer light. Okay, if you have a battery, one battery, and you're adding more bulbs, you're exhausting the energy supply from the battery. And so hence the brightness will decrease of all the bulbs, okay? Because you've got energy conservation. Whatever comes in has to come out. So you've got energy coming in into the light bulbs that's got to get used up and converted into light. Lots of energy means lots of light distributed across many globes. So that's another disadvantage. So dimmer light. Let me do the pros and cons for parallel circuits below. Pros, well, the first pro is if one bulb fails, rest stay on. This is basically the opposite of a series circuit, okay? The opposite for the con. The rest stay on. Another advantage is that the voltage is the same throughout the circuit. That's a good thing because if you have, let's say, if you look above your heads now, let's say in a classroom, you will notice that the lights all share the same brightness because they've got the same voltage, because the voltage is the same throughout the whole circuit. In other words, there's energy reaching equally all parts of the circuit. So the voltage is the same throughout and you get equal brightness. Then the pros, the cons, unlike series circuits which are easy to connect, parallel circuits are complex and so they're harder to connect typically. There's a lot more wiring involved. If you look at your household lighting, a lot more wiring. It takes more time consuming. Disadvantage is that the current, another disadvantage, current isn't the same throughout circuit. Unlike in series circuits where there's one big loop, only one pathway for current, in parallel circuits, that's not the case. There's different branches. So they're the two cons for parallel circuits. So to summarize, series circuits, they involve components connected in series, one after the other, forming one big loop. Parallel circuits is basically when you have components connected in parallel in different branches, and so you have multiple pathways for current to flow.